All right, the second video for our chapter 1, section 1, we're dealing with the domain and range. The question asks, for the following exercise, find domain, range, and all zeros, intercepts, if any, of the following of the functions. So I've used one of the problems here that we're going to discuss. First of all, the definition of domain and range are above. I pulled this out of your book. So it says a function f consists of a set of inputs, a set of outputs, and a rule for assigning each input to exactly one output. The set of inputs is called the domain of the function. The set of outputs is called the range of the function. So the domain are your x values and your range are your y values. And you can also look at it alphabetically. X precedes y and domain precedes range. So if you that's how I remember it, to remember which one's which. Okay, so I've got a function here, and we have to determine the domain and range, and then we'll get to zeros and intercepts if applicable. So we have a square root function in the denominator. So we've got a couple issues here. One issue is that we can't have a 0 in the denominator. So anywhere our denominator would be 0, our function would not be defined. We would have a problem. So here, since the denominator can't be 0, x can't equal 9. Because 9 minus 9 is 0, we can't have 1 over 0. So we know that that's a value we can't have. So the other rules, and that's the only way that we get a 0 in the denominator. So as far as a fraction is concerned, that's the only thing we have to have an issue as far as our domain goes. The other possible problems that we're going to have is we also can't have a square root be negative. So note square root of x has domain of 0 through infinity. So we can't put a negative value in the square root. So that means that x minus 9 has to be greater than 0, which means x has to be greater than 9. And this is actually going to be our domain. We know that x can't equal 9 for the above reason, but our domain is x is greater than 9. So what sort of range can we have here? Well, we have a fraction. We can have a very small number in the denominator. If we take something like 9.001, we're going to have a value where we have 1 over a tiny fraction, which will get us a large number. So our graph is probably going to look something like this, where, say, this is 9. Let me just draw a little dotted line here, and let me change some colors. Our graph is probably going to look something like this. Again, we're not going to be able to get it to 0 because our numerator is not in any way, shape, or form going to get us there. If we had an x up there, we could deal with that, but we don't. So that's what our graph is going to look like. So our range, we can't actually be at 0. So x is going to be strictly greater than 0. And you can write these in other ways. Instead, if you prefer, you can do 0 to infinity with the parentheses as opposed to the bracket. But this is how you would do domain and range for a problem like this.